chapter 25 is matched pairs. Doing a hypothesis test and a confidence interval for matched pairs data. The problem says, one indicator of physical fitness is resting pulse rate. 10 men volunteered to test an exercise device advertised on TV by using it 3 times per week for 20 minutes. The resting pulse rates were measured before the test began, and then again after 6 weeks. Results are shown in the table. Is there evidence that this kind of exercise can reduce resting pulse rates? And then if so, by how much? So notice here's our 10 men, and their names are kind of funny. They're labeled Alan, Brandon, Carlos, David. It's the letters of the alphabet. These are their resting pulse rates before they use the exercise machine. And then after 6 weeks, these are their resting pulse rates after. So if the machine's working properly and they're getting in better shape, their after pulse rate should be less than their before pulse rate. So like Alan didn't improve at all. Brandon's pulse rate dropped 4 beats per minute. Edwin's dropped 4. Franco dropped 8, so he must have worked hard. Ivan actually got worse. He had 1 more beat per minute after doing all the exercise. So the question is, are their after numbers less than their before numbers? Now, one thing you'll notice, both sets of data came from exactly the same people. So we can't do this as a 2-sample t-test because we break the 4th condition, which is the groups must be independent. These groups are not independent. They are the same people, providing each piece of data. So we will not do a 2-sample t-test. What we end up doing is a t-test on the differences between the 2 numbers. So the first thing we do is we actually find the difference between each value. And since the before should be higher than the after, I'm going to subtract them that way. So 73 minus 73 is 0. 83 minus 79 is 4. 85 minus 81 is 4. 87 minus 86 is 1. And I just keep doing this. Ivan's difference is -1 because his before is actually less than his after. So this column is the difference between the 2. So this becomes our set of data, and we'll do a 1-sample t-test. So we're still going to use phantoms. So P is the parameter, and we're going to say that M with the lowercase d here, a subscript, is the true difference in pulse rates before and after the trial. Now for the null hypothesis, since this is a 1-sample t-test, is what we're going to end up doing, we're going to say the null is that the mean difference in pulse rates is 0. That would imply that there's no change from before and after. That when we add up these differences, they're going to average out to 0. And that would mean the machine didn't work at all. The alternate hypothesis will be that the mean difference is greater than 0. And we're doing that because a positive number here means that there was improvement. That this is actually means that they had 4 beats per minute less after exercise. And we're looking to see if we reduced resting pulse rates. A is assumptions or conditions. For conditions, there's basically 2 you need to check. Number 1, we'd like a simple random sample of the data. And these were volunteers, so unfortunately it's not a random sample. That simply means that this data, or our results, will only apply to these guys. So we could say something like, no random sample, results only apply to these people. The second thing we need to check is that we have a nearly normal distribution of differences. So that means we're going to have to make a histogram of this data and check it out. So on our calculators, I have already entered the data. into L1. Hopefully you can see that. We're going to do a histogram. Okay. Now, it's not great, but it's also not super bad. There doesn't seem to be any super strong skew. Okay. So we'll say, for the purposes of this, that we're going to move on and say that this is okay. Now, the picture would look like this. We always put the null in the middle, and the null was that the difference was 0. Now, I actually have to find the difference, so I could do stat calc, one variable stats, and I find that the mean difference is 2.8 beats per minute. Okay, so that means there was a 2.8 beat improvement. The standard deviation on my calculator was 2.5, using the sample standard deviation. So that means my standard error would be 2.5 over the square root of 10, because there were 10 people. So n is name the test, and we call this a t-test, or a one sample t-test, and we should report the degrees of freedom as 9, because I'm going to take 10 minus 1 is 9. The test statistic, just to check the equation, it would be 2.8 minus 0 over the square root of, or over 2.5 over the square root of 10. And then I'll also get the p-value. So now I just do a one sample t-test on this information. I'm going to use the data, since I have it in a list. The null is that there was no difference, and I'm trying to see if the alternate is that it's greater than 0. So my t-score ends up to be 3.5, and my p-value is 0.003. So obviously my decision is going to be reject the null, and my conclusion is going to be because of the small p-value, reject the null. We have evidence. The exercise machine reduces pulse rate. So a couple things that are different about this. We always talk about the mean difference between the two groups. So our data, even though it comes to us in 2 columns, we're going to make it 1 column of data by subtracting and finding the differences. And then it's just a one sample t-test. And then, of course, we could create a confidence interval to see what the actual difference is. And you'd do the same thing, parameter, conditions, name the interval. It's a t interval with degrees of freedom 9. And then we would actually make the interval, which would just be a t interval. So I go stat, test, t interval is 8. Make sure my confidence level is 95%. Calculator's thinking, and I get 0.99 to 4.6. So about 1 to about 4.6. So we are 95% confident. The actual difference in pulse rates is between 1 and 4.6 beats per minute. So remember, the reason why we're doing this is because we don't have independence between groups. Our data comes from the same group of people for both sets. So because of that, it breaks the 4th rule, or the 4th condition of independent groups. So then what we do is perform a one sample t-test. And we always do it on the differences between the two groups.